So we'll go ahead and get started. I am just passing out part 2 of section 5.3. We're going to exclusively just look at the side-side angle type of problems today. These are the ones that I said possibly have no solutions, one solution, or two possible triangles. Okay. So first thing I want to point out about this section, there's a couple things that I've added that aren't in the textbook, namely this box that's at the bottom, the steps involved in solving these. But there's possible different scenarios, and I'm not going to make you memorize all these different cases of when you get one solution or no solution, or but in the case that, so what you're going to be given is you're going to be given essentially an angle and two sides. Okay, so you'll be given an angle alpha, side length C, and then side length A. So angle, side, side, or if you like, side, side, angle. And in the case that the given angle is obtuse, between 90 degrees and 180, in that case there's two possibilities. You might not be able to form such a triangle, or there at most is one possible triangle solution. And then in the case that your angle is acute, if the given angle is acute, there's actually three different possibilities. You might not be able to form a triangle, and there might be possibly one solution, or there might be a way to take side A and form it in two different ways. Okay? And rather than try and memorize all of these, what I did was I've devised a little step-by-step process at the bottom of the page that you can just follow that little process to determine if you have 0, 1, or 2 solutions. Okay, so again, you're given two sides and an angle, and it's possible that you can't form any such triangles. There might be one triangle, or you might be able to form two triangles that meet the criteria. Okay, so these are possible scenarios. If you're interested, you can read the textbook. There's an interactive figure that might explain why in each case you would either have one solution, two solutions, or so on. But I'm going to deviate from that a little bit, and I'm just going to run through this little process that I have with everybody. Oh, well, sorry, let me turn that back on. My bad. Oh, I don't have my hand out though. Okay, never mind. I'll have to write this down on the board. Or we can all read it together. Okay, so what you're going to be given is you'll be given two sides and an angle, so side-side angle case. And what you're going to do is you're going to first, since you have sides A, I'll turn that off in a second, so as soon as it starts blinding you. What you're going to do is you're going to be given essentially A, C, and alpha. So you're given two sides and you're given the angle alpha. And I guess you could kind of start drawing this, although the picture will be misleading. There you go, sorry. Let me get this shot. Come on. I think it has to turn on 100% before I can turn it off. Come on. There we go. Okay. So you're given A, C, and alpha. And I'll draw a picture, but it's kind of misleading because, right, there's situations where all three angles in the triangle are acute, or there's the case where one is obtuse and two are acute. But I'll just kind of draw the all acute situation. So you'll be given some angle alpha. The side opposite alpha is A. Here is side C. Okay. And the angle you're going to always try and find first is gamma. So I guess first try to solve for gamma. Okay, that would make, yeah.
Do you want gamma to be the other side or the other angle of the base? Or can we use the top angle as well?
Well, I mean, eventually we'll have to find this angle, but notice you aren't given any information about this side. So if you have alpha on opposite side A and you're given C, if you're going to use law of sines, this angle would be the first natural thing to try and find. Because we have law of sines would say sine alpha over A equals sine gamma over C. Okay. And then since we don't know the angle beta or the side opposite to it, it would be best to use this expression when we're trying to find gamma. Okay. So if you look at these steps, okay, so in the box at the bottom it says first try to solve for gamma using law of sines, okay, and then converting to arc sine. So if you look at this expression right here, I can multiply by C on the left. You'd get sine gamma is C sine alpha over A. And then what you can do from here is you can solve for gamma by doing sine inverse on both sides. So I'm just kind of outlining the steps here before we look at an example. Keep writing gammas when I mean alphas. There we go. So that would be step one. First try and solve for gamma. And there's two possibilities. And everyone has copies. Now, so that would be step one. And then what does part A say? If you try to plug this in your calculator and it says domain error, that's going to mean there's no solutions. Okay? That means that C sine alpha over A is not in the domain of sine inverse. Okay? Which means that there is no possible triangle that satisfies the initial given values A, C, and alpha. Okay? So I guess, where's my... Maybe this red one works. So I guess I can say step one, solve for gamma. And then there's two possibilities. So if you compute this value, if you get a domain error in your calculator, there are no solutions. That means we can't really make a triangle with side lengths A, C, and alpha given. So that's what you're crossing your fingers for, right? You hope you get this case, because then you're done and you don't have to do any more work. Okay. However, B, if there is not a domain error, a triangle exists. Okay. So find other sides and angles. Okay. Now, you wouldn't necessarily be done at this point either. Okay, so whatever you get for gamma here, that might be one such triangle. And let me kind of draw the picture. Let me see if I can do this to make it. So let me draw the picture to kind of show you where a second triangle would come from. Okay, so that's one. You set up your law of sines, you solve for gamma. If you try to plug this in your calculator and get a domain error, there's no such triangles that with the given side lengths and the angle. If you don't get a domain error, then at least one triangle will exist, and you can find the other side and other angle. Okay. And then here's kind of the situation. Here's what happens. So I'll use red. Okay, so again, that's C, that's alpha. Now, one of your A values, it might be here, but it's possible. I'm trying to draw it with the same length here. Okay, but maybe I could form two different triangles. So either the big triangle with all the red sides, or maybe just this triangle over here might also work. Okay. And then I have to see here, if this is gamma, I believe that this is going to equal 180 degrees minus gamma. So there's a little bit of an argument that can be made using 180 degrees. So this is where the second part comes in. So if the solution to the first triangle exists, okay, maybe it's this big triangle I've drawn in the picture. Okay, then what you can do is maybe instead of this being your gamma, maybe now you can have a second gamma for a second triangle. Okay, so what you do here is, if a solution to the first triangle exists, you would calculate a second possible angle, gamma sub 2, and it's 180 degrees minus the first one. Okay. And again, I'm going to skip through the argument, but if a first triangle exists, this other angle over here just ends up being 180 degrees minus that one. Okay. And then two possibilities now. Okay. So this angle alpha that was given, that's actually in both triangles. It's got to be the same angle. So the first one, if the given angle plus the possible new angle, if those are greater than or equal to 180 degrees, you don't have any room left for another angle, right? Because all three angles have to add up to 180 degrees in a triangle. Okay, so if you try to form the second possible gamma, and you add it to the first given angle, and it's greater than or equal to 180, there is no second triangle. Okay. So you would only have one solution. There'd only be one triangle you can form with the given sides and the angle. And then finally, B says, if the original alpha plus the possible new gamma in the second triangle, if this ends up being less than 180 degrees, then that would mean you do have room for a third angle. Okay. So then a second triangle or second solution exists. So find all other sides and angles. Okay. And again, this isn't in the textbook, but I thought it would be better to at least have some sort of process that I think this is easier to remember than what they have in the book. Okay. So again, you start by trying to solve for gamma. So you set up your law of sines, and then solve for gamma with sine inverse. If you get a domain error, there's no triangle with the given sides and given angle. If you don't get a domain error, there's at least one triangle, and then you can find the missing sides and the missing angle. And then if there was a first triangle or first solution, you can possibly build this second triangle with A, C, and gamma given by just saying gamma 2 is 180 degrees minus the gamma from the first triangle. Okay. But if that added to the original alpha given is greater than or equal to 180, there is no second triangle. Right? You wouldn't be able to find a third angle if two of the angles are already bigger than 180. Okay. And then if alpha plus gamma 2 is less than 180, then there would be room for a third angle. And then that would give you a second triangle, and you go find the missing sides and missing angle. Okay, so we're going to look at a couple of these. Hopefully in my three examples I've got one where there's no solution, one where there's one solution, and one where there's two solutions. Okay. Alright. So is it okay if I erase this? For the most part, I have this on page 1 of the handout. So example 1, part A. Let's see, did I give you A equals 10, C equals 6,
A equals 120.
and alpha is 120 degrees. Okay. Now, one thing you know for sure, if you look at table 5.3 on the first page, if the given alpha is an obtuse angle already, the only possibilities are no solution or one solution. Okay, so really step 2 of my box at the bottom wouldn't apply here. There's only possibly at most one triangle that's going to work here. Okay, so if you're doing side-side angle and the given angle is obtuse, there's at most one possible triangle. Okay. All right, so again, kind of think of my picture up here. I can call this angle down here gamma. Let me just get rid of that for now, just so we have the picture. Okay, again, beta and B are not given. Okay, the only thing we know are A, C, and alpha. So the only thing you could solve for first is gamma. So you can set up your sine alpha, which is 100 degrees, 120 degrees over the side length 10, would equal sine of gamma over its opposite side, which has length 6. If you like, I can draw this in the picture. I guess I'd have to draw a different picture here because alpha is really obtuse here. And then A is going to be 10, C is going to be 6, and here's gamma. So if we have a triangle, that's what it's going to look like. And then first I would solve for sine gamma. That's 6 sine of 120 degrees over 10. And then I'm actually going to enter all of this exactly. If you plug this into your calculator right now first, you might not get an exact value. So what I'll do is gamma then is going to be sine inverse of all this stuff, 6 sine 120 over 10. Make sure your calculator is in degree mode. Okay, so you can do second sine inverse. I got to switch to degree mode. Fraction button, and then I'll do 6 sine of 120 over 10. Let people see. Anybody get a value yet?
About 31.31.
Okay, so to 2 decimal places, you should get 31.31 degrees. Okay. So again, if you look at table 5.3, in the case that the given angle is obtuse, there's at most one solution. And since we did not get a domain error trying to calculate gamma, we know that we'll be able to find a triangle that works. Okay. And now you can find the missing angles. So this is going to be beta, and the side length on the bottom is going to be B. And we now know gamma is 31.31 degrees.
It's going to be 28.69 for beta.
So beta is going to be what?
28.69.
So what do? I just take my...
180.
I take 180, subtract the
120 and the 31.
120, so I subtract alpha, and then I subtract the angle we just found, and you said that equals what?
28.69.
Okay. So beta can be found by starting with 180 and then subtracting the other two values, the other two angles. Okay. So I have beta. I got all 3 of my angles. The only thing left is just finding that side length B. So what am I going to do to find side B now?
It did sine 28.69.
Okay, so you did sine of the angle beta.
Yeah, 0.69. over
degrees over B. That's the
equals
side we're
sine
trying to.
120.
And you did a equals sine 120 degrees over the side
10.
length A, which is 10.
Do we just give you what I got?
Yeah, I'll write it down here because I guess I can multiply B to the right and then multiply by the reciprocal of this. B should be 10 sine 28.69 over sine of 120.
Which is 5.54.
Okay, so again, it's 5.54.
Is this the side?
Mm-hmm.
Is this the side?
Yeah.
Yeah, this is the side B.
Why don't you just use the Pythagorean?
Why didn't I use Pythagorean theorem, Maddie?
Because it would only work with right triangles.
So yeah, be careful. Don't use Pythagorean theorem. It only works if one of your angles is 90 degrees. Right? That doesn't. And the reason why that doesn't make sense is any non-right triangle, the hypotenuse doesn't make sense, right? So again, everybody okay what I did? I just put the B up here, and then I multiplied by the reciprocal on the left. That's how I solved for B. So start working on the second one, see what you can come up with. Some of you might have already beat me to it, but. By the way, how many possible triangles could you have in this part B? Yeah, now you have an acute angle for your given angle, so there might be up to 2 triangles that work. Okay, so again, if you draw your picture, just to help you at least know what the sides are. So this time alpha is acute. The side opposite has length 5, and then gamma is in the lower right, and the side opposite gamma is C, which has length 9. So step 1, use law of sines. What would you set here? Sine of 40 degrees over 5 has to equal what?
Sine C over 9.
Sine gamma over side length C, which is 9. And then you can multiply both sides by 9 to solve for sine gamma. And then finally gamma is going to be sine inverse of all this stuff on the right. But what happens this time?
Error.
Did you get a domain error? So this, I guess you can say, this is undefined, if you like. So remember, the domain of sine inverse is numbers that are strictly between -1 and +1. So the problem here, I believe, is that this expression right here is greater than or equal to +1. So when you try to plug it into sine inverse, it's not in the domain, so you get a domain error. Okay, so no triangles exist in this one. No solutions exist. And that's the easy one, right? Okay, so we tried to find gamma first. didn't work because we got a domain error in the calculator, so there are no triangles where A is 5, C is 9, and alpha is 40 degrees. You just can't build one at all. It doesn't work. Essentially, what this is kind of saying is that side A is too short. You know, it might be the case that side A stops right here. Right? There's no way this side's ever going to come touch the base. That's what's happening here. Okay? So in the case that alpha is acute, A is too short to meet with the third side. No matter how I try and swing this around. You'll see this picture in the book if you look, but if you imagine swinging this around, you'll never be able to touch the third side. Okay, so that's why there's no such triangle that's going to satisfy this. And then part C. So this time A equals 7, C equals 9, alpha still 40 degrees. So we're still in the case now where Alright, so this time A might be long enough. You might come down and touch this third side. It might be possible, though, your A could have come this way. Okay. So again, I think if I set this up correctly, I should have an example where there's two possible triangles that can be formed. Okay. So again, what do you start with first? You want to solve for gamma, so you start with law of sines. Sine of an angle over its opposite side is the same as sine of any other angle over its opposite side. Okay, so I started with law of sines. Solve for sine gamma. That's 9 sine 40 degrees over 7. So gamma is going to be the inverse of all that stuff. Alright, any issues here then? Let me wait and see. Anybody try to plug this in their calculator yet? Did it work, Martin?
It worked for me.
So what did we get?
For C,
For angle gamma, yeah?
55.73
So 55.73?
degrees, yeah.
Okay. So there's at least one solution. You guys all right?
Yeah.
Okay, cool. So let me know if you have a question, if there's something that I'm not explaining that well. Okay, so again, in the side-side angle case, you're always going to solve for that angle opposite side C. Set up your formula for law of sines. And then solve for sine gamma first, and then apply sine inverse to both sides to get your angle. This time we get 55.73. Okay. So before there might be a second possible triangle that will work, but let's finish this one first. So we'll find again the angle beta, and we'll find. So also notice we're in this case, right? This bottom right angle that's acute. If there's a second angle, we'll do 180 minus this. Gamma will be obtuse in that case. Okay. So what do I want to do now? What do I solve for next? Okay, so you're going to find your third angle beta. So beta is going to be 180 degrees minus the two angles that we know. And what do we get there? What did you get? 84.27. Okay. So now we have all the angles of our first triangle. Now you need a third side. So we knew the beta up here, now we need a side length B. So now you apply law of sines again. So sine of this beta angle 84.27 over its opposite side B, which is the last side we need. We'll just use, is it better to use the sine alpha over 7 probably? Because this was an approximation. So let's use the exact values, sine 40 degrees over 7. And then again, I'm going to multiply both sides by the reciprocal of this and then just move the b to the right. So multiplying both sides by b, and then you're going to get 7 sine 84.27 degrees all over sine 40. Let me move this over just a little bit, actually. Anybody have a value for me? 13.84? 10.8.
Yeah, go.
Anybody get something different, or are we okay? Now here's something interesting I want to point out, and this will help you think about this. The longest side is always opposite the longest angle, right? And then the next longest side would be opposite the next biggest angle. The next biggest angle was gamma, so the side opposite that should be the next longest. And then finally, since alpha is the smallest angle, the side opposite that should be the smallest length. Okay, so this answer makes sense. Okay, so there's one solution. There's the first possibility. And then, like I said, the second possibility might be the triangle where gamma is obtuse this time. You still have this side being length 9, this side being length 7, and this is still 40 degrees. Okay, so the second angle for a second triangle, gamma 2, if it exists, what does it say on the sheet?
It should be 180 minus.
Yeah, in step 2 it says if there is a second triangle, gamma 2 ought to be 180 degrees minus the first gamma. Minus 55.73 degrees.
So get 124.
What'd you get? 124.
0.27 degrees.
Okay. So maybe there's a second triangle where gamma is an obtuse angle. In that case, it'd be 124.27. Okay. And then let me just circle all these from before. Okay, so what am I going to do to determine if there's a second triangle now? If there is, gamma has to be 124.27. So yeah, now we still have this 40-degree angle. That plus my new gamma those have to add up to be less than 180 to be able to even make a third angle. So notice that alpha plus gamma 2, which is 40 degrees plus 124.27 degrees, this is 164.27 degrees, which is less than 180.
For that third angle, you'll get 15.73.
Okay. So everybody okay so far? We found our first triangle. If there's a second one, gamma 2 better be 180 minus the gamma from the first solution, which is 124.27. As long as that adds with the first given angle to be less than 180, there will be a second triangle that works. And Kirsten, you said beta 2 would just be take your 180 degrees, and then you can actually just subtract the 164.27.
And I got 15.73.
You get 15.73. Okay. So there's gamma 2 in our second triangle. There's beta 2 in the second triangle.
value to use log signs to get the B2 or.
Yeah, let's label this. Let's call this beta 2 and call this B sub 2. I'm just using subscript 2 to mean that it's the solutions to the second triangle. So I think it's going to be really, just use law of sines again. So what can I set up here? Well, I can do sine beta 2, 15.73 degrees over B sub 2. And then we'll do that equals sine of the original angle over its opposite side, which had length 7. And then you can multiply 7 on the left, divide by sine 40, multiply both sides by b sub 2. You'll get 7 sine 15.73 degrees over sine 40 degrees. Can someone remind me what our first b was real quick? 10.84. Okay, thank you. I just wanted all the answers to the first one over there. And Chris got 2.95. I'll write approximately. Okay, so 7 sine 15.73 over sine 40 was approximately 2.95. Okay, so both these triangles have the same A value, C value, and alpha value. The only thing that might change is the other missing side and the other two angles. Okay. So in this case, you had in the first triangle, gamma is acute, and then we went and found the other angle and other side. And then we took 180 degrees minus the first gamma to get 124.27, and then we just used the same process to find beta 2 and the side opposite beta 2, which was B essentially. So there's two triangles that could have been formed with the given information. And hopefully adding this little procedure here for knowing when you can form a second triangle or not, hopefully that's helpful. Again, it's not in the book, but it should be helpful. Remember, if you're doing side-side angle and the given angle is obtuse, there's at most one solution. And if the given angle is acute, like it was in this problem, right, we started with a 40-degree angle, then in that case there's possibly two solutions. All right, any other questions, maybe homework questions? Should I throw another example up there? We could do that. So I'll give you another side-side angle. Okay, so what if okay, so solve the following triangle. So let's say A is equal to 8, C is equal to 9, and alpha is equal to 55 degrees. So, anybody try finding gamma yet?
Yeah.
Did we get a domain error? Nope. Oh.
It would have to be less than 7, because that's approximately what the last problem was.
It's probably pretty close. But what did you start by doing? I guess you could write it this way. Sine gamma over... So if you're going to set up law of sines, what did you get for an expression? So sine gamma over 9 equals sine of the given angle over its opposite side of 8. So you need to solve for sine gamma and then take sine inverse on both sides to get gamma. What'd you get for an angle? 0.15? Okay. And then, one thing you might notice too, as long as gamma is bigger than this other angle, there will always be a second solution. Pretty sure. Although, let me think. No. Maybe that's not true. I would just follow the steps of doing 180 minus that and then adding back the given angle to it. Okay, and then what'd you do now to find, for the first triangle, what'd you do to get the other angle on other sides? Okay. Okay, so you're going to find beta first. So beta was take your 180 degrees, subtract both given angles. And what'd you get for this one? What was it? 57.85. Okay. And then you have to use what again to find the other side? Okay, law of sines one more time. So we know gamma, beta, and then now I'm going to do it the other way because it makes it easier actually. B over sine of beta equals A over sine alpha. This way you just have to multiply both sides by sine of the 57.85. You get 8.27. So there's the two angles in the third side for the first one. Take a look at that quick. Anybody get something different, or is there something I could maybe explain? We got 5 minutes to get the other triangle. Okay, so law of sines to get the angle gamma. Then you can subtract both those angles from 180 to get beta, and then use law of sines one more time to get side B. Okay. Okay. And then now what do I have to do? If there's a second triangle, what's the gamma going to be in the second triangle? Okay, it's going to be 180 degrees minus what your first gamma was. So gamma 2 is going to be, is it 122.85?
112.
Or 112.85. Okay. Okay, so if there's a second triangle, remember, A, C, and alpha are going to be the same, but now those other three values might be different. And again, if you wanted to see where it is, it's kind of drawing, you're drawing this down so that this is a copy of alpha. I guess I could explain where that's why we're doing the 180 minus. If this is gamma and this is alpha, I'm drawing a dashed line so that this is now also alpha, or sorry, gamma. But if that's gamma, this is a straight line, the other angle is 180 degrees minus this one. That's how I'm getting that other obtuse angle. Okay. So that's why I'm doing the 180 minus. Okay, and then where do I want to go from here? Can you now find your third angle first? So beta 2, which would be this angle up here now, this small one, that'd be the beta 2. Right here, that angle is the gamma 2. And what did you say it was? It's 180 degrees. Oh, what did I have to check first, though?
You need to see if it's less,
You could
Yeah.
just
when you
check.
add the other.
Yeah, if you take this second gamma and add it to the given angle, it's going to be less than 180.
Can you just do the 180 minus 112 minus 40, and if you get a negative number, then it's not possible?
Yeah, you could do that too. You could, once you find your second gamma, you could try to find beta if it's a negative number, like Kirsten said. That's another way to tell you there's not a second triangle. Okay, so I'll subtract gamma 2 and subtract alpha. What'd you get for this?
27.5.
27.15.
Yeah. Oh, shit.
Yeah, I think that makes sense.
Yeah. No, I messed up earlier on, so maybe I didn't
Okay,
change my
so you got
number.
12.15? Okay. And then what would you have to do to get your beta b sub 2 now? You can plot reciprocals, so 0.15, and then divided by sine of the corresponding angle, which was 55 degrees. And then you can just multiply the sine over to the right.